Welcome to Pre-Calculus. Let's work on finding the relative extrema of our last two examples. We had looked at two examples already. Well, let's head to our notes screen to see two more functions to find the relative maxima and relative minima. So our next function is f of x equals 1 over x plus x over 4. And like we've been doing, we want to start by creating a table of values for the function. And we'll populate that left column with our x values. Those are our domain values. They're independent. And we're going to find our dependent values there in the right column, our f of x, another name for y values. So let's go ahead and place our domain, and let's give this one our traditional -2, -1, 0, 1, and 2. For this function, let's head over to the Desmos graphing tool to get our y values. And we'll type in that function just as we saw it printed. So f of x equals 1 divided by x, and then I got to click to the right to exit the denominator, plus x over 4. And there's our function. So if we do want to graph it, I'm going to hit the edit list and convert to table feature. And I'm going to record those 5 values. So notice at 0, we've got a vertical asymptote. We can see it in the graph, it says undefined. We can also see it here on the graph itself. There's no value for the function on the y-axis. On the left of the y-axis, we're down in quadrant 3. So our output at -2 is -1. -1 has output of -1.25. And then on the right of the y-axis, the whole branch is in quadrant 1. So there's one part, 1 at 1.25, and then at 2, our output is 1. Let's go ahead and head back to our note screen to finalize that table with this information from Desmos. So we did see that at 0, it was undefined. And I'm going to sketch that vertical asymptote to represent that undefined x value. At -2, recall, we had the value of -2. I'm sorry, of -1. And at -1, we had the value of -1.25. At 1, we had the value of positive 1.25, and 2 had the value of 1. Let's graph these points. So at -2, we are at -1. -1, we're at -1.25, so slightly lower than that y value at -2. At +1, we're at 1.25. And at 2, we're right at 1. So that gives us opportunity to sketch this graph. So from the left here, we start below, and notice this whole left branch is included here in quadrant 3. The right branch is all in quadrant 1. So it descends, and we've got our graph. So we've completed that first step to create the table of coordinate points and then use that to graph the function. Now we want to determine the relative maxima and relative minima for the graph. So remember, we're looking, when we're talking about maxima, what's the highest point on the graph? And the relative minima, what's the lowest point? And because, again, these are not absolute maxima, absolute minima, we're looking for the thing that's highest relative. What's a hilltop for the maxima? What's a valley for the minima? So looking at this graph, I believe that there's something there on the left, and that looks to be a relative maxima. And ironically, that whole branch is lower than this right branch. But again, we're saying it's relative. It's relative to the curve that it's on. Similarly, here on this right branch, it looks like I got a valley, kind of a low spot. That's our minima. So definitely you want to keep your wits about you when you're identifying the maxima and the minima. Because they're relative, they could be on a part of the graph that's lower than the other one if it's a maxima. And similarly, it could be on the higher part of a graph if it's the minima. Well, let's locate those points using the Desmos feature. So on the graph, we had identified that this point right here was our maximum. In fact, that's one of the points we recorded, -2, -1. The minimum point is also one we recorded at +2, +1. So we'll head back and we'll finalize this labeling for our maxima and minima. So the maxima here is at -2, -1. And the minima is at +2, +1. That completes our second task. Now let's finalize this question by finding our intervals of function increase and decrease. So let's highlight our intervals of increase in the green. So from the left, it looks like this left-hand branch is increasing up to that x value of -2. So I'm going to say it starts over here in the x direction of -infinity and increases all the way up to that relative maxima at -2. Past that, it descends, so it decreases. When I pick up on this right-hand branch up here in quadrant 1, it also starts by decreasing. But then as it reaches the relative minima at 2, 1, it begins to increase again from the x value of 2 all the way to forever, which we'll indicate as +infinity. Well, we'll finalize by picking up the intervals of decrease, which we have already noticed on the graph. We just have to write the intervals. So the one here on the left-hand branch in quadrant 3 starts at the x value of -2, and it descends forever as it gets closer and closer to the x value of 0. So that interval is from -2 to 0. It also decreases here on this branch in quadrant 1 from 0 to our x value of +2 at the minima. And that completes the analysis for intervals of increase and decrease on this function 1/x plus x/4. Let's see, one final example. So this function involves a square root. This function is x times the square root of x plus 6. We'll begin by creating our table of values. X and f of x. Again, the x column is our domain. And let's start here. Since I'm seeing this +6, I'm going to put -6 and on. So -6, in fact, let's back up and put -7 so we can see what happens there. So -6, -5, -4, -3, -2, -1, and 0. And we'll go to 1. So definitely, let's calculate this one by hand. It looks like it's easy enough that we could calculate by hand, at least these first couple values. So for this first x value of -7, we're going to calculate f at -7. And I'm going to substitute -7 for any x value. So that's -7 times the square root of -7 plus 6, which is -7 times the square root of -1. -6 plus 6 is -1. Now, I've run into a problem. I can't take the square root of -1 in the real numbers. So what I would say here is that this value is undefined. And that happens with square root functions. Once it's negative under the radical, we can't do anything with the evaluation. It doesn't exist in the real numbers. Let's see what happens at -6. So -6 is substituting in for all these x's. So that's -6 times square root of -6 plus 6. And under the radical, -6 plus 6 becomes 0. So this is -6 times square root of 0. Square root of 0 is 0. And -6 times 0 is 0. So that's going to be our x-intercept, our 0. -6, 0. Let's try at -5. F at -5 is -5 times the square root of -5 plus 6, which is -5 times the square root of 1, which is -5 times 1, or -5. So that evaluated real cleanly. -5, comma, -5. Now we run into some irrational numbers at this x equals -4. So f at -4 is -5 times the square root of -4 plus 6, which is -5 times the square root of 2. And I'm going to estimate, square root of 2 is about 1.414. It goes forever and it doesn't repeat, so definitely it's irrational. That value is going to have the approximate value of -5.66. I've run this on a calculator. So -4, comma, -5.66. We're going to see this for a while. So until we get another perfect square under the radical, we're going to have these irrational outputs. And that's okay. I made a mistake. Let me go back. I input -5 here. Can you see what that should be? That was an x in the function. My x here is -4, so that should be 4. But that is -5.66. So fix the error. Let's keep going. So -3 square root -3 plus 6 is -3 times the square root. -3 plus 6 is +3. And again, that's irrational. So I got to estimate that that's about -5.20. F at -2 is -2 times the square root of -2 plus 6. And it looks like we're in luck here. -2 plus 6 is 4. Square root of 4 is 2. So I can put these firm equal sign. This is -2 times 2, which is -4. Let me catch these 2 points. -3, comma, -5.20. -2, comma, -4. We'll keep going. So f at -1 is -2. I'm sorry, -1. About to make the same mistake, but we won't. -1 plus 6 under the radical. And that evaluates as -1 times the square root of 5, which is, I got to back up to give the wavy equal sign since it's an approximate value of -2.24. We'll record that. So -1, comma, -2.24. And then f at 0 is 0 times square root of 0 plus 6, which I really don't need to think about that square root because 0 times anything is 0. This function goes through the origin. And our last output, it's a f at +1. F at +1 is 1 times the square root of 1 plus 6, which is 1 times square root of 7. That's irrational again, which has the value of about 2.65. 2.65 times itself would be 7. Well, that gives us enough to graph this function. So let's place these points on the coordinate plane. -6 is at 0. And that's really where this function begins on the left. -5 drops down all the way to -5. -4 descends further to negative 5.66. Negative 3 is going back up to negative 5.20. Negative 2 is at negative 4. Negative 1 is at negative 2.24. 0, 0 is on the graph. And 1, 2.65. So a little past 2.5. And that gives us opportunity to graph this function. So it looks like a kind of a candy cane or a shepherd's crook where it descends and then increases on the right-hand side. So that completes our first task, just to graph the function. At this point, we want to identify any relative maxima or relative minima of the function. So definitely we can see that this end of the fishhook is for sure a relative maxima. It's relative again because this whole right-hand branch is higher than that left-hand point here at negative 6, but it does represent a high point on the graph. So I'm going to put the point negative 6, 0, just based on our table of values. That's the first point where this function is defined. We also seem to have a relative minima down here at the bottom of that fishhook. Now my hypothesis is that that is at the x value around negative 4, but to make sure, I'm going to head over to Desmos to use that graphing feature and see. So let's clear out this previous function that we'd graphed, and we'll type in f of x equals x. The square roots here on the keypad in the main grouping of functions, so square root of x plus 6. And then we see our graph looks very similar to the way we graphed it. And definitely as we select that trough, the bottom of the fishhook, it is that value at negative 4. That confirms the hypothesis. So let's go back to our note screen, and we'll pen in that point. So the relative minimum is at negative 4, and it has the value of negative 5.66 about. So that completes the second task. We found the relative maxima and the relative minima. And our last task is to record the intervals of function increase and decrease. So let's outline the increase in green. So this first part of the graph from negative 6 on is not increasing. That is for sure decreasing. So I'm going to start here at the bottom of the fishhook and go up and to the right to positive infinity. So that interval is from negative 4, the x value of the minima, to positive infinity. Let's catch the last part here. The last part is to identify the intervals of function decrease. So that's in the purple color. And that was what we looked at first. It's from the x value of negative 6 where the function's first defined. And that whole function goes down to the x value of negative 4 at the minimum. And that completes our graph and our analysis of this function f of x equals x times x square root of x plus 6. Thank you for joining. Thank you for graphing and analyzing. See you next time.